Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called 7 Lines by Stephen Richards. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. We have digits in the larger white circles must appear at least once in the 4 surrounding cells. So for example, 1, 3, and 7 must appear in the 4 surrounding cells around this circle, this quad circle, which is what we call them. And this circle must have a 1, a 4, and a 5 in the 4 surrounding cells around this quad circle. So those are examples of how quad circles work. Digits on a pink line form a set of consecutive non-repeating digits in any order. We also call these Renban lines. So for example, you could have something like 7, 8, and 6, and this would be a valid Renban line, because we have a set of consecutive non-repeating digits. 6, 7, and 8 form a consecutive set of non-repeating digits. You could not have something like, say, 5, 7, and 8 here because that's not consecutive. And those are examples of how Renban lines work. We have digits on the blue line have the same sum in each box that the line passes through. So this digit must be exactly the same as this digit because they sum up to the same sum, and these are only a single digit long, and they sum up to the same sum as this set of 3 digits. And these are called region sum lines. So that's an example of how, so you could have something like, say, I don't know, 1, 4, and 2. And that would work if this is 7 and this is 7. So these are examples of how the region sum line could work. We also have a black dot separates digits where one is double the other, and a smaller white dot separates consecutive digits, and these are otherwise known as crop key dots. So for example, say this was a 2 here, then this would have to be 1 or 4 to maintain the 1 to 2 ratio that's between them. And say this was a 6 here, this would have to be 5 or 7 to make sure that these digits are consecutive. And those are examples of how crop key dots work. And finally, we have digits in the cage summed to the number in the top left corner. So these digits must add up to 9, so you could have had 1, 5, and 3, and this would be valid because these 3 digits add up to 9. And these are also known as killer cages. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, so we have in this upper right-hand box and this lower left-hand box 2 sets of quads. And in both of these quads, there has to be an 8. That means this cell must be an 8 here, because this requires an 8 surrounding this quad, and there has to be an 8 surrounding this quad, and the only way that 8 can be there to be surrounding both of those quads is here. So this is 8. We have a similar situation in the upper right-hand corner. This has to have a 7 surrounding it, in the 4 cells surrounding it. This must have a 7 in the 4 cells surrounding it. Where can 7 be? Where it's surrounding both this quad and this quad, it has to be here. This is a sum of 3 unique digits. To be able to add up to the sum of 3 unique digits, you have to be either 6, 7, 8, or 9, right? You have 1, 2, 3 adding up to 6, 1, 2, 4 adding up to 7, 1, 2, 5 adding up to 8, 1, 3, 4 adding up to 8, and 1, 2, 6, 1, 3, 5, or 2, 3, 4 adding up to 9. Well, this can't be 7 because of the 7 already in the box. This can't be 8, and there must be the same digit because of 8 in the box. So this is either 6 or 9. Well, if this were 6, then this would have to be 1, 2, and 3 adding up to the 6. But the problem with that is if this is 1, 2, 3 as a triplet, that means this has to be at minimum 1, 4, and 5, and that adds up to 10, which is greater than this cage can ever add up to. And that's the minimum. So therefore, you'll never actually work in that situation. Another way of putting that is anytime you add up to a single digit for 3 unique digits, you are guaranteed 2 of those digits must be from 1, 2, and 3, at least. So, right, you have 1, 2, 3 adding up to 6, which requires 3 digits from 1 through 3. 7 is 1, 2, and 4, which requires 1 and 2, which are 2 digits from 1 through 3. And to add up to 8, you have 1, 2, 5, you have 1, 3, 4, both of which require 2 digits from 1 through 3. And to add up to 9, you have 1, 2, 6, 1, 3, 5, or 2, 3, 4, all of which require 2 digits from 1 through 3. So we know these 3 cells must require 2 digits from 1 through 3. These 3 cells must require 2 digits from 1 through 3. Therefore, neither of them can be 1, 2, or 3, right? If we have 1, 2, 3 here, we need another 1, 2, or 3 from here, but that's 4 cells which would require the digits 1 through 3, which is not allowed. So therefore, that's why we know this can't be 6 either way. I showed it in both ways, so this is 9, that's 9. We have to have a 1 and 3 surrounding this quad. So this is 1 and 3. And because this is 7 and 9, there's no 1, 3 available anymore. Surrounding this quad, we have to have 1 and 5, and we can't have 1 or 5 in either of these spots, so this is 1 or 5 here. Surrounding this quad has to be 6 or 7. Okay. Therefore, this adds up to 9, and this adds up to 9. Therefore, all the 1, 2s, and 3s must be in this set. So this must be 1, 2, or 3 to count as 1. And you have another 1, 2, 3 here, and you have another 1, 2, 3 here. That means none of these can be 1, 2, or 3. You could have 1 with this being 2, 6, and 3, 4. So 1, 2, and 3 cannot appear anywhere else in this central box. These have to be 1 through 6 as possibilities. This cannot be 5 because 5 can never be double another digit or half another digit. If you have 5, you get 2.5, which is not a single digit, which is not a digit. And if you double 5, you get 10, which is not a digit. That's the reason why this can't be 5. Surrounding this quad must be 1, 4, and 5. Where are 1, 4, and 5 then in this left central box? We are guaranteed a 1 and a 5 here in columns 2 and 3. We are guaranteed a 1 and a 5 here in columns 2 and 3, which eliminates 1 and 5 in the rest of the column. So in this left central box, 1 and 5 have to be here. Interesting. This cannot contain an 8. So as a 3-length remband, you don't have 1 or 5 available. This is 1, 4, and 5. For a 3-length remband here, you cannot have 2 and 3. So this must be 6, 7, 8, or 7, 8, 9. We're guaranteed either way. This must be 6 or 7. Or 7, 8, 9, which means this can't be 8 because of 8 in the column. This can't be 7 because of 7 in the column. So 8 has to be one of these two, and 7 must be one of these two. Where else? This can never be 1 and 2 as a 1 to 2 ratio because we're guaranteed one of these has to be 1 or 2. This cannot be 3 and 6 then, either. If this is 3 and 6, that would force this. It cannot have 1, 2, 6 adding up to 9. Cannot have 1, 3, 5 or 2, 3, 4 adding up to 9. So that eliminates all possibilities for this cage if this is 3 and 6. So this cannot be 1, 2, cannot be 3, 6. Therefore, it's guaranteed to have a 4, which means this cannot be 4. So this has to be either 1, 2, 6 or 1, 3, 5, which means there's a guaranteed 1 here. So this cannot have 1 in the rest of the box. So this must be 4 with 2 or 8. This can't be 8 because of 8 in the column. Sorry, 8 in the row. We have a 1, 5 guaranteed here in rows 7 and 8. We also have a 1 and 5 surrounding this quad, which means it's guaranteed to be in rows 7 and 8, which eliminates 1 and 5 remaining in rows 7 and 8, similar to this scenario. So 1 and 5 have to be in this row here, in this lower central box. We should do it this way. Yeah, we have guaranteed 1 and 5 here. Similarly, we have a quad here which has a 1, quad here which has a 1, so that's guaranteed 1 in one of these cells, 1 in one of these cells. So that means in the rest of rows 2 and 3, same with 1s here and the 1 here. In column 7 and 8, we cannot have a 1, so 1 has to be guaranteed to be here and must be 1 guaranteed to be here. Remaining digits in this lower left-hand box, we have 2, 3, 4, 6, 7, 8, and no 8, 6, 7. This can't be 6 or 7 because the 6 or 7 must be surrounding this quad. So we have, in this Renban, a 7 guaranteed in columns 1 and 2. Around this quad, we have a 6, 7 in guaranteed in columns 1 or 2, which means 7 in this left central box cannot be in columns 1 or 2, it must be in column 3. Well, for a Renban now, this cannot contain 1, 5, or 7 as a 3-length Renban. Can't contain 8 either, so this must be 2, 3, and 4. That's the only set that works. Without 1, 5, or 7, or 8, 6 doesn't work, and 9 doesn't work, so this must be 2, 3, and 4. That 2, 3, 4 triplet eliminates 2, 3, and 4 in the rest of the column, so this cannot be 2, 3, 4, it's 6 or 7 here. These can't be 6 or 7. So we have 1, 5, 6, 7, or 9. This can't be 9 because of 9 in the row. This can't be 7 because of 7 in the row. And this can't be 7 because as this Renban works, we have to have 6, 7, 8, or 7, 8, 9 here. So we have 2, 3, 4 here, which is consecutive with that digit. Well, this can't be 2, 3, or 4. So this has to be a 1 or 5 here, consecutive with 2 or 4. Okay, this is 5. We have 1 or 5 here, and 2. So for this, in this lower right-hand box, we also have a 3-length Renban without 1, 2, or 5 available. So that means 3, 4 cannot be part of this. So again, this must be either 6, 7, 8, or 7, 8, 9. And 8 cannot be here, so 8 has to be one of these 2 digits. 7 can't be here because of 7 in the column, so 7 must be one of these 2 digits, which means 7 has to be one of these 3 digits here. 7's here, 7 has to be one of these 2 digits, so this can't be 7. This has to be 7 here. 8 is one of these 2, so 8 cannot be on this. 8 has to be one of these 3 digits there. This is guaranteed to be 4 here. So if this were a 2, it would have to be with 3 and 4 on a Renban because 1 cannot be there because of the way that the quads work. But if 2 is here, that would mean 4 has to be here, but we know 4 has to be one of these two in a 1 to 2 ratio. So this can't be 2, this is 4, which makes this not 4. 8 is here, 7's there, 7's there. 8 is here, 8 is here, so 8 has to be one of these three. This kind of forms a Renban, but it's even more restrictive because this digit must have to be has to be between these two digits. We cannot have 1, 2, or 3 here. You cannot have 4, 5, 6 as a triplet. You can't have 5, 6, 7 as a triplet because, again, these add up to 9. And it's either 1, 2, 6, 1, 3, 5, or 2, 3, 4. So it cannot be 3, 4, 5, 6, cannot be 5, 6, 7. It could be 6, 7, 8, or 7, 8, 9. So we're guaranteed an 8 here and a 7 here. So this has to be 7 possibility as 6 and 8, or 8 with this being 7 or 9. And either way, this is 7 or 8. This cannot be 1, 2, or 3 because, again, we have the 3, 1, 2, and 3 are accounted for in these sums. And this can't be 7 or 8, so this is 4, 5, 6, or 9 here. Excuse me. 4 cannot be consecutive with 5 without 5 here if there's no 5. So this has to be 4, 2, and 3. Which means this can't be 2, so this is an 8. That eliminates 8 here. 4 is consecutive with 3 or 5, but this is 4, 2, 3, which eliminates 4, 2, and 3 in the rest of the box. So this must be a 5 here, which means this cannot be 1, 3, 5. It's 1, 2, and 6 here, which eliminates 1, 2, 6 in the rest of the box. So this can't be 2, 6. No 6 here, no 2, 6 here, no 6 here. This must be 7, 8, and 9 to be consecutive. So this is 8 consecutive with 7 or 9, which eliminates 9 in the rest of the box. And this 6 eliminates 6 in the rest of the box. So this is 3, 4, 5 as a triplet. We are guaranteed a 3 here. So that doesn't really help us much. Anyways, remaining digits. So this is 1. It can only be consecutive with 2, so this can't be 1 here. 2 can be consecutive with 1 or 3, but this can't be 1 or 3. Because 1 can't be here because of the way the quads work, and this Renban eliminates 3 from being there. So this can't be 2, this is 6, which eliminates 6 here. 6 is consecutive with 5 or 7. 5 cannot be here because of the way that the quads work, so this must be 7. So this is 7, which eliminates 7 here. 3 and 4 is in a 1 to 2 ratio with 6 or 8 or 2. So 2, 6, or 8 here. It cannot be 8 because of 8 in the column. Therefore, 7 cannot be there. 5 can't be either of these. This is 1. We have 2, 3, 4 here, which eliminates 2, 3, 4 in the rest of the row. We now have in this lower left-hand box a 6, 7 pair, which eliminates 6 and 7 from the rest of the box. So this can't be 6 or 7. We have remaining digits in column 4 are 3, 7, and 9. 7 cannot appear in either of these spots, so this must be 7. Therefore, this must be a 3, 9 pair. Okay. Where is 9 in row 4? These are consecutive, and this has to be 2, 3, or 4, so this can't be 9 here. 9 cannot be here because it must be with the 7, 9 pair to surround the 8 here. So 8 and 9 both have to be here. If 9 can't be here because of 9 in the column. If 9 were here, that would guarantee an 8 on this Renban. But we know 8 has to be one of these 3 cells. So this can't be 9 either. Therefore, this must be 9 here. And we have to have an 8 somewhere here. We're not sure which. 9 eliminates 9 as a possibility in the rest of the column. We are left with a 6, 7 pair in row 8, which eliminates 6 and 7 in the rest of the row. That leaves the remaining digits as 1, 5, and 9. 9 can't be here because of 9 in the column. We have a 1, 5 pair now in the rest of row 8, so this can't be 1 or 5, it's 9. The remaining surrounding cells around this quad are 1, 2, and 5. So this is 1, 2, and 5. And this 9 eliminates 9 here. So this is 6, 7, 8 as a triplet, which leaves this as a 3, 4 pair in this lower right-hand box. Okay. Can this ever be 8? You have 8 here. You would have to have a 7 on this Renban, and you can't have a 7 there because of 7 in the column. So this cannot be 8. This is 8 here. So this Renban has to be either 2, 3, 4, 3, 4, 5, or 4, 5, 6. Either way, you need a 4 here. This can never have a 1. So where is 1 available in row 4? It can only be here. So this is 1, which makes this 2. 1 cannot be here. 2 cannot be here. Cannot be here. That leaves this as 3, 4, or 5. That's fine. 2 is guaranteed to be one of these 2 digits here, because it must be 1, 2, and 5 here. So this cannot be 2 here. So 2 is one of these 2. 9 being here would have to have 7 and 8 to be consecutive with it. And so it cannot be 9. This must be 3, which makes this 9, which eliminates 9 from being here. 3 eliminates 3 being here, so this is 1, which makes that not 1. That's 3. 1 eliminates 1 here, so it's 5, and this can't be 1 or 5. It's 2, which forces this to be 1 here. 3 eliminates 3 here. So as a Renban, you don't have 1, you don't have 3, 7, or 9. So this must be 4, 5, and 6. So this is 4, 5, 6 as a triplet, which eliminates 4, 5, 6 in the rest of the column. This can't be 6, it's 8. This can't be 8 here. So it's a 6, 7 pair. That leaves this digit as a 2. This can't be 1 here. So this is either 3, 4, 5 or 2, 3, 4. So either way, we're guaranteed a 4 here. 4 cannot be here surrounding this quad. 4 cannot be here surrounding this quad. Where is the 4? It must be here. 7's here, so this cannot be 7. We have a 4, 5, 4, 5 pair in row 4, which eliminates 4 and 5 in the rest of the row. This can't be 4, it must be 3. And these 2 digits add up to 6. And these 2 digits must then add up to 6. We don't know which is which. 3 is in a 1 to 2 ratio with 6. So that's 6 there, which eliminates 6 here. We have a 1, 5 pair in column 2, which eliminates 1 and 5 in the rest of the column. This can't be 5. It's 6 or 9. So this is 6, 7, 8, 9 as a quadruplet, which eliminates 6, 7, 8, 9 in the rest of the box. This 1 eliminates 1 here, and we need a 1 and a 5 surrounding this quad. So this can't be 1. That's 5, which makes this 1, which eliminates 1 here. So it's 5 and 1. Okay, we have a 6, 7, 6, 7 pair in column 2, which eliminates 6 and 7 in the rest of the column. So this can't be 6, it's 9, which eliminates 9 here. This has to be a 2, 3 pair. This can't be 2 because of 2 in the row. So this is 3, which makes this 2. That eliminates 2 from being here. Where is the 2 in this lower left-hand box? Can't be here anymore, can't be here. So it has to be here. So this is 2. 3 eliminates 3 here, so that's 2 and 3. Where is 2 then in row 2? Can't be here because of 2 in the box. Can't be here, so this must be 2 and 4 on this Renban. That leaves this as 6 or 8. This can't be 6 because of 6 in the column, so this is 8, which makes this 6. This can't be 6 anymore. That's 7. This is 8. 7 eliminates 7 here, so it's 6 and 7, which eliminates 7 here. So that's 6 and 7. Where we should have 8 2s. We don't. This is a 1-2 pair then, because 2 cannot be here, whereas 2, it has to be one of these two, and 1 also has to be there, so this is 1-2 as a pair. This is then 3-7 as a pair. That 3-7 pair eliminates 3 and 7 in the rest of the column, so this can't be 3. That's 4, which makes that 3. 4 eliminates 4 here, so that's 3 and 4. Remaining digits here are 5 and 9. Remaining digits here are 6 and 8. 8 eliminates 8 here, so this is 6, which makes this 8. 6 eliminates 6 here, so this is 4, 5. We have a 4, 5 pair in column 8, which eliminates 4 and 5 here, so that's 6. Remaining digits of column 7 is a 6. Remaining digits of column 9 are 4 and 5, and this can't be 4 because of 4 in the row, so this is 5, which makes that 4. That leaves, this 4, 5 pair eliminates 4 here, so this is 2, which makes that 4. Remaining digits of row 1 are 1 and 5, but this can't be 5 because of the 4, 5 pair in the column, so this is 1, that's 5, which makes this 8. Remaining digits of column row 7 are 6 and 7. This can't be 6 because of 6 in the column, so that's 7 and 6. 7 eliminates 7 here, so it's 9 and 7. Remaining digits of row 9 are 1 and 9. This 9 eliminates 9 here, so it's 1 and 9. 9 here eliminates 9 here, so it's 5 and 9. 5 eliminates 5 here, so it's 4, and this becomes 5. 3, 4, and 2 add up to 9, which makes this 1. 2 eliminates 2 here, so it's 1 and 2. 7 eliminates 7 here, so it's 3 and 7. 3 eliminates 3 here, so it's 4 and 3. And 4 eliminates 4 here, which makes this 5 and 4. Thanks for completing my first and possibly last puzzle. I hope you derived at least as much enjoyment from solving it as I did making it. Not that I can quantify this in a meaningful way. Hopefully it's not your last. It was a very good job. I thought it was really well constructed, especially for your first puzzle. Really well done. And I hope it's not your last one. But if it is, you know, it is what it is. But I did enjoy solving this, so nice job. Nice job at creating this puzzle. It was a lot of fun to solve, and hopefully we can see more puzzles set by you. But if you have to do what is enjoyable to you. So, either way, I just wanted to express that this was a lot of fun to actually solve. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.